Hey guys, this is part 3, and today we're going to talk about variables and data types. So let's get started. So what is a variable? A variable is used to represent some data. It's like a storage location located somewhere in your computer's memory. Now variables could hold any kind of information, ranging from numbers, letters, and memory addresses. A variable is like a box that holds certain types of information, and you can open that box to grab that information, and you can use that information in some way to manipulate it. So, more on variables. To make a variable, you first have to tell what type of information it will be holding. So this is the identifier type. Then you have to give it some sort of name so you could retrieve it. You have to use the name to retrieve that location in memory. And at last, you'll need to assign some kind of value that fits the data type. So this process is known as initialization. Here we have the syntax down here. We have the identifier type, space, the name, the equal signs. Now this equal sign is called the assignment operator, and it takes whatever is on the right hand side of it and it assigns it to the left hand side of it. So that's the syntax, basic syntax for creating and initializing a variable. So we have some rules we have to follow in order to create a variable. First of all, we know that uppercase and lowercase letters are distinct from one another. So this all capital lock num here they're not the same as this lowercase num. They're different, they're distinct. So variable names cannot begin with a number. So this int for num is invalid. Variables begin with a letter or an underscore character. But keep in mind, this is a reminder or note, beginning a variable with 2 underscores or an underscore and a capital letter, it isn't illegal to create it, but it is reserved for the implementation. So they could be as long as you want. With some platforms, they may have a length. Right down here, this is a valid variable, and it gives it the value of 45 to this long integer variable. Variable names should be meaningful and provide a general idea of what the variable is. Don't give a variable name X or something. You want to give it something like meaningful. And you can't use C++ reserved keywords like if, else, or double. So we have 2 data types here. We have fundamental and compound. Today we're going to look into fundamental. Later on, we're going to look at compound, which includes strings, arrays, and structures, and pointers. So fundamental has 2 major groups, the integrals, or the whole numbers, or the floating point, which are numbers with a fractional part. So here are the fundamental data types. And we have the integer, the short, the long, and then C++ 11's new edition, the long. Then we have Boolean values, character values, double values, floating point values, and long double values. And each of these data types has 2 modes. It has a signed and unsigned version. So these are the integrals, the whole numbers. We have the char, which is short for character. We have short, int, long, which is included in C++ 11. We have bool, which is short for boolean. All of them can be either signed or unsigned. So let's take a look at what signed and unsigned numbers are. Signed numbers are numbers that can store a negative value or a positive value. And unsigned is a number that cannot store negative values, only positive values, and therefore the maximum value is double. If you don't specify if it's a signed or unsigned, then by default it's a signed variable, meaning it could be negative or positive. Let's take a look at this. For example, we have a short, and on this platform it's 16-bit or 2 bytes, and the range of values it could go from on a signed short, meaning negative to positive, we have negative 32,000 to positive 32,000. But unsigned short, we have 0 to 65,000. See how it's doubled? And not all data types are the same on different platforms. So here we have a table of integers that are signed. This is signed. Note that 1 byte equals 8 bits, and I'm not going to really go into this because you could copy this and pause the video to look into it. It just talks about the minimum value, the maximum value, how much bytes memory it takes up, and a little declaration example here. Then we have the unsigned again. No, there is no Boolean sign here. But yeah, these are double values and they can't have a negative. And here's also a declaration example. So what data types should I use? So C++ has a lot of data types for integers. It has short, unsigned short, int, unsigned int, long, unsigned long, 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 and unsigned long, long. And you should use values that will never be negative. So if you want to store a number that's never negative, like let's say the population, then you should use unsigned data types. If you want to store like the number of stars in the galaxy, or I don't know, you should use long. That's used to store very long numbers. And if you want to use small numbers, just put it into short. The most natural data type that mainly used is the int. So let's look into the char data type. So char is used to represent single characters. I had a little mistake here. And each character has their own code behind them. So characters are represented with a number code. So if we look at the uppercase A, it's represented with 65. So the number code system is ASCII character set, and many systems support fewer than 128 characters. Each character is a byte in size. So this is how we initialize a character. We use the char keyword, and a name, and then the equal sign, and then the character surrounded in single quotes, not in double quotes. Single quotes are for characters, double quotes are for strings. So I provided a link here for the ASCII character set. It provides the whole table. Not all characters can be represented by a keystroke. For example, the enter key to make a new line. You must use something called escape sequences, which I will cover later. If we look here, we have \n. This is used to make a new line character or the return key. Also on ASCIIcode.com, you can look at different bases for numbers like octal, hexadecimal, and so on. So here I have a little sample program. It says int main cout, and then it's just asking, it's outputting to the screen, please enter a character. And I create a variable here, a ch. It's called ch, it's type of char. They did not define it yet, but I use cin to input data into that variable, and then I just print out the screen. You enter the key and then the key. So this is pretty cool. So when the user enters the keystroke, say for example the character M, on input it stores the character code corresponding to that character 77, but on output it displays the actual character rather than displaying 77. So now let's talk about Boolean values. Boolean also falls under integer types. It is used mainly for logic. It's created by the mathematician George Boole for algebra. It has two states, false, which is 0, or true, which is 1. Anything that is non-zero evaluates to true. Any non-zero value evaluates to false. It will output into the screen either 1 or 0, not the text, true or false. So let's talk about the second major group of fundamental data types, the floating point numbers. It includes these three data types. It includes the double, the float, and the long double. These data types are used to represent numbers with a fractional part, such as negative 1.54, 3.14, or pi, 1.04, and so on. So remember, integers are used to hold whole numbers, while floating points hold fractional part numbers. So here we have a table of floating point data types. These are all signed, they can't be unsigned. And again, 1 byte on this system is 8 bits. I'm using Windows 7 64-bit. And the float, just the table here, shows the minimum value, the maximum value, how much it takes in memory, and then an example declaration. Note that on some systems, long double won't be the same. It'll be maybe bigger. It could be 128 bits. I'm not sure. It depends on your operating system. So in here I provided a list of constants to use. But before you use these constants, you have to make sure that you include these two header files. Just like including IOStream, as well you include climits and cfloat. Climits is used for the integer types. It provides a lot of constants for the whole numbers. And cfloat is used to provide constants for floating point numbers. So we have with these you could output to screen the maximum number you could have for short or unsigned short, and then you can have maximum number you can have for double. You may want to pause, or I'll provide a download link to this PowerPoint presentation. And then there's one more thing here, the int and data type. This type can allow you actually to set the amount of bits you want for an integer. For example, we could say it starts with 2 underscore characters, int 64. So int 64, we're saying here we want an integer that is 64 bits, that is 8 bytes. And then we also give here the name, the identifier name, and then we assign some kind of value to it. Then the size is 8 bytes. Remember, 8 bits is 1 byte, well, depending on your system. So, int 30, here we declare int 32y, it says 4 bytes, and so on. So, we could determine the size in bytes of data types, actually. There's a built-in operator into C++, it's called the size of. You could provide it either the data type, or you could point to a variable. But either so. So if you say size of int, you put it into parentheses, or you could point it to the variable, like here, example, double x, and I'll bring this out to the screen. It'll return to you the amount of bytes that particular data type has. So for example, int on my system is 4. Double is 8 bytes. So this part was just a PowerPoint presentation. Part 2 will look into more stuff and actually into the code. This was just to give you a general understanding of it. Alright, thanks for watching. Bye.